that I forgot to post something. I'm sorry, I'll do it right after class. About participation in iEval, evaluation of the course. So the educational team of the university and me also, we are very interested to know about your ideas, about your comments about these courses. I know the summer course is very condensed, it is long, uh, but about the content of the course, and even you have any idea about the format of that. I myself am uh, uh, pro shorter courses, okay, shorter lectures. So I think that 50 minutes or 1 hour, 20 minutes are perfect. When it goes to almost 3 hours, I think efficiency decreases. Even I have breaks after 1.5 hour, 1 hour, 20 minutes. Anyhow, any ideas that you have, please participate in eval. And I'll open an assignment page on Canvas. If you drop there the screenshot of the participation that you have, um you will get 10 points, 15 points. Let me increase it to 15 points and encourage you to participate. So please don't send the receipt or the screenshot of your participation or email that you receive from iEval to me by email, because my email is not connected to the grade book. But I'll make a page on Canvas under assignments that you can just spend a few minutes and participate in this iEval and drop the screenshot there, and then you get 15 points. You will have time until, I'm sorry, tomorrow, I believe, or let me double check it. And it just takes a few minutes to do that. Okay, any questions, folks? Nothing? Note about iEval. Where's my notebook? Wow. Start. Take a note. Okay, folks, let's continue the lecture. We are discussing the third book that we had by Dalnick. It is called Clockwork Universe, and it has mostly a social, it discusses mostly the social aspects of scientific revolution, and it tries to illustrate the society, European societies, and specifically England during the scientific revolution, and find out what kind of philosophies were there, what was the life of people, what was in the uh, uh, mind of these forerunners of the scientific revolution. Okay, we talked about the Royal Society of London. It was the first scientific society which lasted for a long, long time and had the very deep impact on the formation of modern science. Before that, we had two small societies, scientific societies in Italy, but because of political change that in Italy happened, they were not able to continue for a longer time. And it was the Royal Society of London, and later, 2 years after the Royal Society, we see the another society established in Paris, the Royal Academy of Sciences. And these two became the hub of scientific activities, modern scientific activities, a hub for great thinkers and scientists there, great experimenters. And also they started to make publications about the discoveries that they had. And it makes this period one of the most productive periods in history of science, because they had labs, they had experimenters, uh, they uh, started to study in new fields and to enrich the classical science that we had, and then publish about the new ideas and make it available for the peers, for other people, and at the same time had an open ear to hear from all critics and other thinkers about the ideas that they had. And it created dynamism, a freedom in we call it horizontal exchange of ideas in Europe, which laid down what we call it the scientific revolution, and later it ended to industrial revolution, or connected to industrial revolution, which is not in the scope of this class. So what do we see here? In these societies, they established a tradition to perform physico-mathematical uh, experiments or physico-mechanical experiments. And what does it mean? How to uh, do experiments and create data to understand nature very well, or at the same time in physical mechanical experiments, how to find out about the physics behind different mechanisms or machinery that they were using, or they newly invented. Uh, so uh, we had obviously a lot of scientists before, like Descartes, Kepler, Galileo. But what happened in a Royal Society? We see a collaboration between all scientists. That was an open, what call arena that people could come, and the high rank scientists, and share their ideas. They discuss every single experiments that they had. Some of these people also, they had their own what call private science. Like last time we learned about Newton, who had his private science of alchemy. But when he wanted to talk about physics, talk about gravity and laws of motion, he published about that, and everybody was able to discuss contents of Principia, or ideas that Newton had about gravity and optics and so on and so forth. So this was a new type of practice of science, but outside, in general, other stuff was other. I'm sorry, I'm losing my uh, vocal cords. I talk too much. Uh, the society was not actually on the same page that these scientists had. So in society in general, we had a lot of other things happening, which uh, had a very deep impact on people's the general people's belief, and uh, the way that they considered the life that time, and the way that they perceived God and its connection with human being on the earth. So two very threatening things that Europeans, most and mainly in England, they encountered were plague and fire. So these two considered as signs of the anger of God, Why? Because people thought themselves sinful. They were not a very good believers. They uh, didn't have a fear of enough fear of God, and they were not good people anyhow. And that's why God wanted to punish them. And plague was one of them, which killed a big number of people in a very short time. And there was no cure for that. Nobody knew what to do. They had the only way that they had to stop it, just going away from the places that the plague was flaring up. And the other thing was fire, uh, either because of the negligence of human being or because of the lightnings, and the buildings that they had was mostly made of wood. So we see uh, that, for example, in London, later in the next slide, you will see that they lost thousands of houses, they lost thousands of people, both for fire and for plague, and they considered them as the, the sign of the anger of God from this people. Middle Ages also was a period that people didn't have a very good hygiene, because it was very difficult to have, I don't know, to have clean restrooms or bath for everybody, to how to warm up the water for taking shower or cleaning the body. There were also ideas, wrong medical ideas, that when you wash your body, you actually open the pores and holes in your skin, which through that infection can enter in your body. We had good doctors, but we didn't have general public, the idea of general public, how to keep the society healthy and clean. And that's why we had back-to-back pandemics and massive what you call casualties of pandemics like plague or cholera and so on and so forth. So everywhere you could find worms, fleas, and I don't know, bed bugs, and it was a common problem. One of the historians calls this Middle Ages as the 1,000 years without a bath. Kings, not and peasants in both sides, they were not paying attention to their public health. Our knowledge about medicine again came from ancient writings, though people in Islamic era like Avicenna or Al-Razi, they had a lot of clinical observations and they wrote a lot of books, but sometimes we see that magic also involves some occult practice involved in medicine. And even in 1685, almost a year that Principia published, you see that Charles II suffered from a stroke, and uh, medical doctors, they performed all these things that you read on this slide. Okay, they I don't know, had back-to-back bloodletting, and they rubbed an ointment of pigeon dung and powder pearls onto royal feet. I don't know, they said the king shaved the skull. And then by practicing all these things, the king died after 4 days. So you see that a mixture of uh, science or common practice from the time of Galen, like bloodletting, mixed with a lot of uh, mystical and what they call magic kind of practice. They were thinking that an ointment of pigeon dung and powdered pearls on feet can have had impact on a stroke. So we see this is a very good example to see that though a bunch of scientists, they were in the process of discovery and coming up with new ideas, but most of these things happening in physical sciences, still in other sciences, we had to wait for more advancement. And whatever these scientists were doing in their club, in their community, would take a longer time to spread among common people, everybody there, to, for example, acknowledge scientific facts like what uh, uh, comets, for example. Again, we're going to talk about comets a lot. Comets were considered a sign of punishment, a sign of disorder in the sky. All the time we had a lot of stories coming from astrology. When you see a comet, a bad thing gonna happen. Uh, the, there were signs of bad omens. But when Newton discovered that comets were members of solar system and they are just moving like other planets, it took a long time for people to admit the scientific fact and then don't scare of comets. So this uh, propagation or admission or assimilation of scientific fact among society always takes a while, and it needs a change in philosophies and in beliefs of people. Okay, 17th century, we can call it a God-fearing century because there were a lot of natural disasters, and they were considered as what warnings about, from God for the sinful people, and it just the way that people live and they act with together, it makes God impatient, and that's why God punished people. They had to confess about the sins that they had. They had to make a list of their sins, and try to what called uh, uh, improve their behavior and practice the way they follow the behavior that expected through what the religious ideas that they had. They were thinking that in the course of history there was no progress. So with the time that Adam and Eve they left heavens and they descended onto earth, they actually came from a perfect place to an imperfect world. And by going back in history, and you see that people were happier. We had more wise people, more educated people. The life was better, and day by day, uh, we are going what towards a chaotic universe and to the end of the universe, when the universe or the world is filled with sin and chaos, and then that's the time that the end of the world happens, and then Messiah comes. You see here and in the documentary that we watched last time, Nathan, by deciphering stories in Bible, he wanted to predict the end of the world. For people like Nathan and some of his colleagues, Bible had two actually aspects. One, it was obviously word, they consider it word of God for common people, but they also considered that there were some hidden facts there, and they had to decipher them. Uh, that's why they interpreted Bible and or other sacred writings by using symbols, by connecting them to other philosophies coming from Pythagoras, from ancient sages, from Kabbalah, from other ideas, and they try to find out about future and what's gonna happen. So both scientists and common people, they had fear of God, and that fear of God shaped their uh, uh, everyday life. They had to uh, just work, go to church, pray. Uh, they have to avoid any sins. They have to uh, what call admit their sins. And you see, even Nathan, again, we saw in the documentary last time, uh, Nathan listed the sins that he committed um, in his life by that time, by 1662, when he was just 20 years old. Yes, he was born in 1642, and this is 1662. And in one of these sins, he talks about he wanted to put fire in their house and burn his mother and stepfather. So uh, any disorder uh, could be a sign of the end of the world, war, diseases, misery, fire, comets, all were signs of uh, what signs of anger of God, because in a regular life, in a happy life, you don't have that many disorders, you don't have disease, you don't have war. But when all these things happens, it means that God uh, tries to warn people that you are getting too sinful and you have to correct your behavior. And among them, comets were very important. Why? Because you can read stories about Jesus, that when he was asked, okay, what heralds the end of the world, he says that war and misery and chaos in heavens. How do you find about chaos in heavens? The best example was a comet or comets, because planets, though they have some weird motions like retrograde motion or eccentric motion, but at the end of the day, they are regular in general. The same thing about the entire what call celestial sphere, about the uh, celestial region. All stars are doing well. There is no disorder there, but comets were sign of disorder, and that's why comets were a big mystery. And the entire medieval period, astronomers and philosophers, they tried to find out about comets. The story changed completely after the discovery of the origin, the celestial origin of comets. So in Aristotle, comets were terrestrial. Aristotle thought that because some exhalations or smokes or vapor are released from the earth, okay, that vapor goes to upper uh, part of the atmosphere, right below the orb of moon, and there it ignites there somehow under the influence of some stars or planets, and they form this comet. So in Aristotle's universe, comets had a terrestrial origin, and they connected it to heat, to earthquake. It was not uh, a sign of disorder in heavens. But what happened in 16th century? First of all, um, a discovery happened in 1520s, 30s, which European scientists discovered that there is a connection between the tail of comet and the position of the sun. In modern astronomy, we know that this tail is formed with the pressure of radiation coming from the sun. Okay, forget about that, about the physics of this, but when you consider it that the sun is here and comet is here, and there is a solar wind or radiation pressure comes from the sun, it sweeps away gases from comet. And now from mid 16th century, we started to think about a celestial relationship with comets. And in 1577, it was Tycho Brahe who discovered that comets were celestial. It created a big, big problem. Why? Just think about this. It's a flashback to what we learned about geocentric model. So, geocentric model was what? Like an onion. We were at the center, and then we had layers after layers of crystalline orbs carrying 7 planets. And then above that, we had fixed stars. Now, Tycho Brahe showed that comets were celestial. Now, the big question was where to put these comets. And we didn't have one comet or two or three comets. Uh, all records that we had by that time showed that people had observed at least 350 comets by that time. Then, if they are moving in celestial region, do they pass through these crystalline layers or these onion layers? Nobody knew. Do they have their own orbs? It was very difficult to accept that because we had too many comets and they were moving on weird paths, where they had weird trajectories, which were not similar to planetary motions. Now, again, we know that comets are moving on very, very elongated orbits. So unlike the planetary orbits, which are very close to circle, though they are elliptical, but cometary paths or orbits are very elongated. So really, it was a big, big mystery. If you remember again in one of the slides related to uh, Descartes' universe, the mechanical philosophy in mechanical what's called system of universe that Descartes developed. Uh, there were vortices there. Each vortex was a solar system. And Descartes theorized about comets in this way, that comets actually were dead stars. When a star dies, it collapses and its vortex collapses. And then this dead star moves in the boundary of these vortices. That's why their path is weird. And according to Descartes, they were dead stars. So even Descartes, in his clockwork universe, should consider comets and their motion, because comets were so important and they were signs of chaos and disorder in heavens. Fire in London in 1666, the same year that Newton had what Annus Mirabilis, the year that he made a lot of discoveries, and he went to his village because we had uh, plague in Cambridge. So you see that both plague and fire actually create a big disaster 13,000 houses were burned in London, including 87 churches. And it was a big question that God even burns churches. Uh, so they consider all these disasters coming from the side of God, and they interpret in this way that God even is angry at what church and even the clergy there. So uh, they had to discover what was going on around. People like Newton, they wanted to find out more and more about God and its creation. Okay. As I explained a few minutes ago, they thought that Bible, obviously they thought Bible was uh, God's word. It actually comes in two layers, in two levels. One is for common people, and there are deep knowledge and secrets in Bible and Old Testament that you have to decipher them. There are stories at the first glance, that's a story, you can interpret it literally, and it gives you a lesson how to be a good person, how to avoid sin. But in the back, there are some hidden information, and this uh, uh, belief in occult and hidden information was in everywhere, not only in Bible, but everywhere around, was a common feature of 17th, 18th century Europe. And Newton himself, for example, he had he had a deep he believed that all figures that you find in Old Testament and in Bible, they were big scientists, they were big thinkers, and they knew way more than contemporary thinkers, philosophers, and scientists. For Newton and his peers that time, Pythagoras, for example, was master of what knowledge, because Pythagoras, I'll explain in a minute, he laid down a kind of uh, mysticism based on mathematics. And for Newton, since God was a mathematician, then Pythagoras was the best person who could be used to, or Pythagorean ideas to decipher mathematics of the universe. Or Moses, Solomon, and many other people uh, were considered scientists. They knew everything. And since that time, say 2000, 5,000 years ago, uh, the common people, they did not have that much knowledge to understand words of Moses and or Solomon. They wrote all these things in a different way, in a mystical way, that they left facts, absolute truth, hidden in their words, and they have to decipher them. So for Newton, God was obviously, and all people that time, God was the author of the universe, but not a mere creator. Okay, if you compare, for example, the concept of God in this period in Christianity and concept of God in, for example, Islam, you will find out there is a big difference there. In Islam, uh, obviously, God is knowledgeable, the most perfect thing that you can think in the universe, but you rarely find any trace of uh, introducing God as a mathematician. Why? Because they think that God didn't need mathematics to create the universe. His mind was filled with all perfect stuff, all perfect designs and creation. And when he thought about, I don't know, planetary motion, it appeared the same way that we see right now. But for Newton and scientists that time in Europe, God was a mathematician which created everything based on mathematics. And why mathematics? Because mathematics contains absolute truth. You can doubt about all I don't know, philosophical ideas. You can doubt, as we saw in the case of skeptical philosophers, even about your existence, that am I really exist right now here, or everything is like a dream, or in modern, using modern technology, we are like, I don't know, digital figures in a digital world, uh, in a metaverse, so that kind of thing. So even you can doubt about your existence, but you cannot doubt about mathematical truth. Questions they ask, like, can God make a circle with corners? It seems a nonsense question, but there was a hidden fact behind that. No, God cannot. God is able to do everything, but he cannot even break the laws of mathematics, because by definition, circle is circle and rectangle is rectangle. And even God cannot break this rule because it is absolute truth. It is defined by God himself. Then, uh, when you believe that mathematical truth is absolute truth and universal truth, 2 plus 2 always is 4 and it never gets 5, then you believe that the universe was built based on this mathematical truth. And God was a specific creator, a perfect mathematician, and a geometer. Okay. So this is uh, an idea which shaped Newton's mind, and many people like Newton, like Leibniz and other philosophers and theologians that time. Uh, then, with this uh, principle, you can define the business or a task of a scientist. What is that? If you discover underlying mathematical rules of phenomena around, you actually discover the way that God created the universe or that phenomena. And then that was one step to learn about God more. Okay. So expand this idea to everything. Expand this idea to microscopic world, for example. Expand this idea to biology and botany. We see this is a period that scientists started to find the mathematics of everything, mathematics of uh, the shape of different leaves of plants, mathematics behind eye. Eye was very interesting for these scientists because that was something that enables us to see God's creation. And they found that it was very, very complicated. They learned little by little about optics. So they learned about the function of lenses. the focal length, how to create an image. And then it opened new questions. Then that image is transferred to our brain. Okay. Descartes tried to explain it. Then, uh, by knowing more and more about geometrical optics, they found, oh my God, this uh, thing that we call it I is filled with geometry, with mathematics, with all optical phenomena. And then God created that, and it shows that God was a mathematician and a geometer. Okay. uh, for again these people, uh, even when they found a flaw in nature, for example, a person with 6 fingers, okay, or we call sometimes this in modern science as mutation. So you find uh, even, I don't know, watermelon. It's not round, it has a weird shape. Then they thought that there must be a reason which this watermelon got a different shape, and you have to find out why did God create this in this way, because God cannot do anything for vain, for nonsense. Everything that he does has a reason, and discovery of these reasons in a mathematical way is the way that we know him. So this was a general idea at that time. There is a book by Herbert Waterfield. He talks about the metaphysical foundations of physical science. So we, in modern science, we have this physical science, which is uh, mostly uh, atheistic or materialistic science. It doesn't have to do anything with creation, with God. But all these things that we see emerged from the mind of scientists and philosophers like Newton, who were looking for what creator in all investigations that they had. So uh, back to Newton again. Uh, in mathematics, in all branches of mathematics, we start from very simple rules. Just open Euclidean, Euclid's book, Elements. It starts with axioms, with uh, theorems, which all of them at the beginning are very simple. Okay, it says, for example, you can consider one number after each number that you count. It is very simple, and you see that that's why we have infinite number of numbers, because you can consider one more. Okay, very simple. Okay, uh, you can find out that I don't know, two parallel lines never cross each other, and so on and so forth. Things like this, and then based on all these very simple uh, rules and principles, you can make very complicated mathematics. Even dive into, I don't know, differential equations. It is difficult. But when you analyze it and go to the first principles there, you find out that it is simple. Okay. Uh, then for Newton, the universe, the entire universe was something like that. Since it is mathematical, okay, since it's mathematical, then it should start with simple rules. And uh, these rules are, since they are mathematical, then there is no confusion there. This is the definition that Newton has, that he is this is the Middle English that they wrote, he is the God of order and not of confusion. Then if you don't understand something, it means that the world is not confused. Phenomena is not formed based on confusion. There must be hidden reality there, absolute truth, mathematical truth, and this is the business of scientists to discover it. It actually continued up to, for example, 19th century. Uh, it is not related to this period, but it just came to my mind right now. For example, Joule, the person we call unit of energy after his name, uh, he was a good believer. He was one of the founders of thermodynamics. And the first law of thermodynamics says that one interpretation of the first law of thermodynamics is um, the the total amount of mass and energy in the universe is constant. Okay, the conservation of mass or conservation of energy or conservation of mass and energy. So he proves it from a physical approach, but at the same time, he has a theological approve of this in this way that, okay, you believe that everything was created by God. He says yes. Then can you destroy God's creation? No. Can you add something to God's creation? No. Then the first law of thermodynamics is verified with this theological interpretation of that. So this was an idea continued up to 19th century and the first half of 20th century, which we had a lot of thinkers putting scientific discoveries or rules in the content of religion and content in the content to connect everything to a creator. So this period also is a period of decline of Aristotle's ideas in all aspects, in astronomy. Aristotle didn't write about mathematics, but he wrote a lot about physics, about astronomy. And you see that day by day they discovered new stuff which were not Aristotelian. Then, so we see decline of Aristotelianism, but they discovered other philosophies. Again, think about this. They were thinking those ancient people were way knowledgeable than the current people. Then Aristotle was not accepted, okay, or declined. But how about Pythagoras? Okay, Pythagoras was uh, a, the king of mathematics that time, or uh, mathematical interpretation of the universe. Pythagoras was the first person who expressed, for example, this relationship between, though Babylonians discovered that before that uh, there's a specific relationship between the sides of specific triangles, the rectangle triangle, a square plus b square equals to c square, but it was Pythagoras who developed this idea and expressed it in a mathematical way. He was the person who discovered about musical notes, that if you have a string, okay, and then you make notes in a mathematical ratio, okay, even in a, for example, recorder here, okay, it has a specific length, and these holes that you see here, they are defined based on a mathematical what rule. When you want to play G, for example, then G's place has a mathematical ratio to the length of this recorder, or I don't know, flute or a guitar or whatever you play. So mathematics was in music, mathematics was in the sky, because the period of the motion of planets obeyed a rule. Okay, their distances, they thought that there was a rule between them. They thought about the number of the planets, okay, and connected it to mathematics. They discovered similar stuff in, I don't know, triangles, in numbers around us. And it was a mathematical approach to understand everything in this universe. So these are examples you see here, which developed by Pythagoras. So you write numbers 1 and 2 comes one row here, and then row next row you create 3. Then you put them together, you create 6 and 10. And you see that by putting these numbers, these dots in triangle, you only can create specific numbers 1, 3, 6, 10, 15, 21, and you continue it and you find a sequence. Why this sequence is there? What was the Pythagoras had obviously his ideas way centuries before in the 6th century BC, but these ideas were connected to what Christianity, where they defined an omnipotent, omnipresent God. We don't know what kind of God was in the mind of Pythagoras, but they redefined everything under what a specific God which was able to do everything, exist everywhere. And when you find all these things in nature, then you find out that God created all these things based on the mathematics that he had in mind. Here, again, a medieval woodcut depicting what Pythagoras and Philolaus, they are uh, examining what the same flute that you see here, mathematics of music behind that. Or for Pythagoreans, this triangle was a sacred triangle because you have all 10 numbers that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they make a triangle. If you have 9, then something is missing here, and uh, there must be a reason for in the creation, in the mind of God, which created everything mathematically. This is the period again we see artists started to discover Pythagorean rules behind everything. This is the famous drawing of human body ratio by Leonardo da Vinci, and he finds what this golden ratio 1.61, which still we are using in many things that we are using, from a credit card size or A4 paper. They follow this 1.6 ratio. And okay, there was a very strong mathematics here, okay, for these thinkers like Newton. God created the universe. You can find a lot of mathematics there. Then God created his replica, which was human being. And then again, you see mathematics here. Discovery of mathematics was one part, interpretation of that was another part of the story. Why it is 1.61? Why it is not 1.72? Then this question actually started a lot of other investigations, though it was in modern science nonsense. If you even discover it is 1.78, you can ask the same question. Why it is 1.78? It is not 2 point, I don't know, 65. Okay. So in modern mathematics, we also really think about these things, but not in the sense of theology. Why the ratio of circumference of a circle to diameter is 3.14? What is hidden there? Or what is the natural e, the number that we have in logarithm and in the natural exponent that we have? What is behind, I don't know, Fibonacci sequence? Why is the speed of light uh, and the speed of electron around a nucleus has a certain what called ratio? All these questions are there, but these scientists, they interpreted all these things uh, based on theology. Theology was the driving engine behind all these scientific discoveries. So uh, that's why we see that Newton spent hours and hours in mathematical calculations. During this process, how to find out about the position or velocity of a free falling object or a planet moving around a sun, they had to calculate the infinitesimal changes in position or in velocity in both. And that's why they were able to discover calculus, both Newton and Leibniz, his contemporary, thinking about the same problems, the same questions. They invented uh, calculus. And if you go to the foundation of calculus, you see that nowadays we are using, I don't know, integration, and we have some rules there. But really, if you go to the original discovery of calculus, you see that it comes with a lot of calculations. And then after all these calculations, they found some general rules, how to, I don't know, find the surface area under a curve. It is very new. We are using very simple rules, but at the beginning, it was very difficult. Uh, so this is a period that revolutions after revolutions have. Calculus itself was a revolution. Newton's Principia was a revolution. Establishment of heliocentric model was a revolution. We had a lot of also new ideas, new approaches in even literature and fine arts, in music, and so on and so forth. A very dynamic period, which uh, makes this period of scientific revolution. Newton's specific behavior in this process was unique. He was one of those people, as you say, who was this Canis. He was the person who bought the personal and private papers of Newton and deciphered actually Newton's private science. Before 1930s, really everybody was thinking that Newton was the founder of this deterministic physics. And there, after 1930s, when he bought them and he spent a lot of money, bought them from the people who heard Newton's writings, he spent a lot of money, and he spent a lot of time to read them and understand what was going on, and started a new era in Newtonian scholarship. But he says that he was, when he had something in his mind, he had to solve it. He had to spend hours and hours to solve it. We uh, have a lot of detailed stories coming from Newton. I can share one with you, that one of his friends once uh, uh, came to visit Newton, and sorry, uh, and actually Newton invited him for dinner, and they had a chicken to eat. Newton told the friend that, okay, let me go and grab a bottle of wine. And he didn't come back. His friend knew that he got something in mind and he had to solve this. Uh, Hours passed and Newton didn't show up. Then the friend ate the entire chicken and put the cover there. And after a couple of hours, Newton came back and just uh, very, what's called, disoriented, and just sat down there, uh, took the cover from the dish, and he said, okay, it was we finished it. It was delicious or something like that. And his friend says that when he passed his office uh, to grab the wine, he remembered something in mathematical calculation, and then he forgot about everything, solved that mathematical question, and then came back. And still, he was doing something with that mathematical problem. And he was with you, but his mind was somewhere else. Another aspect of this period was the promotion of experiment. Again, we saw in the documentary, and now this is the Newton's own handwriting, that he wanted to understand, discover about the impact of the shape of the eyeball, the way that we see stuff. So he studied lenses very well. He uh, had a lot of publications about optics. He knew the function of lenses and geometrical optics. He believed in uh, what's called particle theory of um, light, unlike other physicists like Huygens, who believed in what the wave theory of light. He wanted to see what's happening when these particles of light enters into eyeball and how do we see. Then he inserted a bodkin, which is a smooth spatula, under his eyeball and pushed it. It is gross, but he wanted to experience himself and describe as a first-hand observer of this experiment what is the impact of uh, changing the shape of the eyeball on the or vision and uh, what happens in this geometrical optics inside the eye. Many other experiments were done that time. Or the most important or a family of experiments were done by air pump. Air pump was there, but the most perfect form of that was invented by Robert Boyle, and it was actually a central part of many physical mathematical experiments. Later, electric machine actually took its place to create electricity, static electricity. And what was this the function of this pump? How to evacuate air, and then many questions appeared after that. We briefly talked about the last time. When you evacuate uh, air, then what's inside that? This question started with another experiment, actually. You fill, for example, uh, uh, what you call test tube with, say, mercury, close the opening of that, and then twist it and make it upside down. You will see that mercury settles down, and then at the top of that, you have an empty space, which what is inside that? The question was that uh, when you are talking about emptiness, then you are talking about nothing. And how can you interpret nothing? They connected this experiment to life. Okay, we know suffocation, and we know that, okay, when we close the openings of our mouth or nose, we die because we don't take and take air. Now, can we do experiments on animals to find out about their reaction with the absence of this air? Then they started a systematic um, line of experiments to examine, for example, with snake, with chicken, with other animals, to find out how do they withstand this situation when air is nothing there or very rare. And then it opened another questions and another studies to find out about, for example, the function of lungs in the body, the function of inhalation in animals, different type of animals. This is the front page of Robert Boyle's experiments in 1660. Okay, and here you see that he writes about physico-mechanical experiments, physico-mechanical, how to find about, to apply physics and to find about the mechanical functions and phenomena around us. This is a very famous painting. It is now in National Gallery in London. And you see here what's happening here. You have Boyle's vacuum chamber, this air pump, and then you have a jar here. Then you evacuate air there, and people are just reacting about. Some people are scared, they didn't like it, they didn't. It was gross to kill a bird there. Some watching very carefully, like scientists. Another person is explaining what's happening there, and so on and so forth. It is one of the most famous paintings from this period. Uh, it is a little here darker, but the original one, it's a little brighter. This image that you, when you see it in the museum, it's very interesting to see how realistic they showed this experiment, which happened in the Royal Society. Also, doing crazy stuff as experiments here. Experiment was the source of new understanding of natural phenomena. So what is the difference between the blood in my body and blood in the body of a sheep? Can we exchange blood or do blood transfusion? And you see again here a theological background here. Why did they pick sheep, not other animal? It comes from what? Bible. We were sheep, and who was our shepherd? Okay, this is exactly the relationship between shepherd and sheep here you see, and it is close. It is we were considered as sheep. Then probably it is the best way or the best candidate to transfer blood. And it is amazing that many of these people who had this experiment, they survived. But later, when people started to practice it, specifically in Paris, they had some casualties and they stopped it until to understand more and more about the blood types and the type of infections that they got after these type of experiments. Okay, how about we stop here for about 10-15 minutes and um, continue the rest of the story, okay, later, okay? I stop recording.
Recording stopped.
And